and sustainable technologies. Over to you, sir.
Thank you for introducing myself here. This session starts with the topic marine hydrodynamics and sustainable technologies. And this session has three presentations. The first presentation is by Sandit Tandaseri, and he is going to talk on innovations in electric powered marine vehicles. And Tandaseri is an award-winning entrepreneur and an advocate for clean mobility in maritime transport. He's a founder and CEO of Novalt Solar Electric Boats, and he has got a bachelor's degree in naval architecture from IIT Madras and MBA from INSEAD. He's a founder of Navagati Marine, and he has ventured into mission for saving energy and saving fuel and saving money. And this is the first time in Kerala we have got solar ferry, Aditya, which was the innovation created by Sri Sandit Tandaseri. And he has got very good awards from various bodies, like the best project award from the World Best Electric Ferry and SET Award for the World Best Startup. And he has published a book titled as Solar Electric Boat. And he is author of many papers, articles on solar electric propulsion, ship performance, analytics, vessel ranging, and fuel predictions. So with this brief introduction, I would like to invite Mr. Sandit Tandaseri.
So all the students here are from the ship technology students, everyone. Okay. So I will talk today mostly on marine transport and electrification. I think in the yesterday and today you might have heard various technologies in the space, but adoption of any technology, finally, economics is what drives it. So I will focus today on the economics and what will be. So we all know that marine transport will be electrified or some green technologies will come, but when and how will be decided by economics. So I will try to give you the framework to understand or to get this answer how and when. So just to give a for understanding or just to group, when I use the word boats, I mean something less than 50-meter length. When I say small ships, it is like 50 to 100, and 100 above is ships. So why I use this grouping is the technology plays different in each of them, right? There is no hard and fast rule defining what is the boundary of a boat and ship, as you already know. Now, when we say energy need in a ship or a vessel, there are two broad categories. One is all that requires for the vessel to move, what we call as propulsion. If you put that as a primary one, everything else can be categorized as auxiliary. Although in this figure I have put electrical as the primary auxiliary energy, in reality it need not be the case. Like you may have a boiler running, heating system, etc. So it could be a fuel to steam and steam to whatever the auxiliary. But for the purpose of analysis, I have used electrical as the base for all auxiliary, which is mostly the case, but there could be exceptions. Now, in any vessel, broadly, there are 5 energy sources, right? So these 5 sources, the first 4 I will talk as a renewable one. It could be a battery. So the energy, what is stored in the battery is a grid energy, like KCB energy, what you call the electricity stored is a battery. Well, solar is obviously the energy from the sun, and wind again, it could be wind to propulsion or wind to thrust, or wind could be wind to electricity as well. Both can happen. Fuel cell is a broad term I have used. Anything, any fuel that is used to convert to electricity is a fuel cell. It could be hydrogen, it could be anything else. And the traditional engine, where the fuel is burned. So these are the only 5 possibilities in a vessel. So if you keep that in mind, and I don't know if you can read, but this is the whole landscape of decarbonization. So when you say decarbonization or new technologies, right? So you can think of one, when you say efficiency, there is something for output and input. So any vessel has a purpose, right? So a function of a vessel is either to move people or cargo or perform a function, right? So this is a broad definition. So you can improve by increasing the output, which is like you may be like reducing the port stays and other. Those are all operational improvements. You can do a lot in terms of improving your design, which is like a lot of energy saving device and various other things. So that's the second broad group. And then this is all related to decreasing the energy need. So when you talk of renewable energy or green technology, a very important thing is how you can reduce the energy need, right? And then of course you shift the energy need into energy source into a greener technology. So this is a landscape of all what is possible in a decarbonization pathway. Now I'm just referring back to the previous slide where I mentioned boats, small ships and large ships. So in most application, when we say boats, you can meet the energy need by solar and battery. In most. Why I use the word most is, in scenario where the speed is high or the range is high, then the battery solar will not work. You may want to do an alternate scenario. And the other extreme, which is a large ship, it is also very clear that battery will not work. Solar can only contribute very little. So which means wind has a play, maybe about 20%. And the rest has to be some clean fuel like hydrogen or something else. So these two are more or less clear. And the in-between ones, which are coastal vessel, 50 to 100 meter vessels, inland vessel, here you need a combination of these, again defined by what is your energy need in a day and energy need between recharging. So that's the driver for combination. Now, when you talk economics, first thing you have to understand what is the cost of energy. So each energy source has a cost. So when I say cost is not merely the cost of the fuel, but what is the cost of energy you get? For example, on the top left is when you say battery as a source of energy. So you have a grid cost. So when I say grid cost is the input cost, you have a battery efficiency, then there is a system efficiency. So you can find what is the cost of energy, electrical energy from a battery by using these terms. So for example, if it's an 7 rupees electricity cost, taking the 90% efficiency of battery and system efficiency of 90%, you get approximately 9 rupees is the cost of electrical energy from battery to be going into the motor. So that's the cost of energy. You get a feel of that number. Similarly, fuel cell has a cost based on fuel cell specific fuel consumption. Solar, obviously solar and wind, you assume that the cost of energy is 0. And then the traditional diesel engine, you already familiar with the specific fuel consumption of diesel engine, which range between, for the large engines, about 175 gram per kilowatt hour, to a small diesel engine or in a boat, which could be 250 or 225, 250 grams per kilowatt hour. That's the SFC conversion. So with that, you can get the numbers. What is the cost of energy? This is usually the starting point when you're looking at economics. This part is to cover which country will the electrification work. So, and why there is a difference in different countries. Just to give you a feel of that, I have just put down the cost of grid electricity on the left side. And then there is on the right part of the column, and CFO, which is the cost of diesel. This is just to give a feel of the spread. So these are ranked by the spread. So the top spread is Hong Kong, where the cost of fuel is very high, electricity is very low, and so on and so forth. So there are all these countries. India is somewhere in the top half, where it is, and these are all in US cents, but just give a feel. 125 US cents means 100 rupees, and 9 cents means about 7 rupees. So that's the number. And in the lower half are Saudi, California, etc., where the spread is low. And I will tell you what that significance is. So if you take those 4 countries, representative countries, Norway in the top, India in the top mid, and like these, the cost of fuel and cost of grid. If you do that and analyze the cost of mechanical energy from that fuel diesel engine, which is what I represent as CEE. When I use the word, it is cost of electrical energy, and CP is cost of propulsion energy. This presentation will be shared, so you can always use that. But I'm just giving a sense of that number. So, for example, in India, with a 125, this is 100 rupee diesel. The cost of electricity from a diesel engine is almost from battery, for example, is 11 and engine is 50, which means roughly about 45 rupees is what electricity you get from a small diesel engine. This one is laser. Okay, thank you. So in India, about 50 cents or 45 rupees is what cost of electricity from a from using the grid from a diesel engine, and this is from a grid, 10 rupee. This is a spread, India spread. So if you compute like this, what you feel, what the spread, when the importance of spread is how easy it is for a country to go electric. So the top countries is very easy, bottom countries are very tough. So India fortunately is in the top. We think electrification will be easy from the number. Whereas California is so difficult to go electric. It's very surprising how Tesla and other companies in US, electrification is adopted only because there is a lot of government subsidy. What I'm saying is without subsidy. Because there are a lot of subsidy, California has the highest electrification, whereas these numbers show it is so tough. So high diesel cost, low grid is when the electrification happens. Second insight you can get is when you take the, like here the number, so for example, 80 cents is electrical from DG and 15 electrical from battery. The spread is 65, 80 minus 15. So that spread is what is plotted here. Norway has 65 auxiliary, 48 as a propulsion. India is 39, 28. What this number shows you is almost always auxiliary has a bigger spread than propulsion. So when you do electrification, the first thing you should convert is the auxiliary load in a boat. So first do auxiliary, then go to propulsion, because auxiliary is always higher cost and thereby economics will work better, which is what we just discussed on a houseboat. So do auxiliary first, do propulsion. If possible, do both. Now, hydrogen is another important element to all this discussion. So today we have a hydrogen vessel in Varanasi, which Cochin Shipyard has built. Today, what is not known is what is the price of hydrogen. It's not very clear. There is no market as yet. In Germany, there are this Toyota Mirai car is there. You can pump hydrogen in a station. It's about 10 euro per kilogram. It is expensive. But I have put the number 532 to assuming that today 5 is possible. 3 may be in the near term, meaning couple of years. 2 in the really long term. Why I say 2 is, although IOC, Reliance all have told they will do $1, theoretically it's very tough because 1 kilogram of hydrogen to electrolyze, you need about 45 kilowatt hour energy, electrical energy. The cheapest electricity if you get from solar, which is about 2 rupees, it means it's still 80, 85 or 90 rupees per kilogram. just the conversion. So that's $1. Then you need another 85 rupees to compress and transfer. So $2 is what is the best you can achieve in 5-10 years. So with this, when you put the same numbers, the same logic applies. Auxiliary first and then propulsion, same logic. But important thing is also, in the scenario when the fuel price goes down to 2, most countries can go hydrogen. In the scenario it goes to 2, not today. In the scenario, like today, hydrogen in India is tough because both OPEX is high and the CAPEX is high. Just to give you a feel of CAPEX, the ferry built by CSL which is operating one, is about 18 crore. It's a 100-passenger ferry. So the cost is so high, CAPEX. Now OPEX is also so high because there's no fuel available now. It's not operating because the fuel is a tricky part. But future is hydrogen, but I'm just saying what is today. So this is the number of countries where hydrogen shift will happen. When it's low, most countries will shift. That is the expect. And this is from an OPEX angle. Now, in reality, there are many energy sources in a vessel. It's not just one. So you have a combination. It's not just one. You have a battery, you have fuel cell, you have maybe a hybrid diesel engine, etc. So all those combinations are there. So how do you do in that scenario? So without going into too much analysis, the whole idea is you are going to know what is the cost of each of this energy, and the proportion, percentage. What is the percentage contribution? It's like weighted average of anything, right? So if this is 8 rupee, this is 0, and this is say 20 rupees, you do percentages, you get the cost of energy. That's the logic. It's a simple weighted average to find the cost of energy in auxiliary side and then the propulsion side. So propulsion means some electricity generated, go to motor, get the propulsion, or diesel engine directly go. These are the only two ways, right? So this is the landscape again for how you will do the conversion and the costing. Now, in the combination, I just want to give an example to just again give a feel of the number. So, sir mentioned about Aditya as an example, as a ferry. So, and why I always argue for solar, especially in slow speed, and I'm very careful and conscious in using the word slow speed when the speeds are 6 knots, 8 knots. This is what I mean by slow speed. Typical ferries. The contribution from sun can be high with the same structure, because the moment the boat is fixed, the area is fixed, your solar energy is fixed, right? So if your boat is going slow speed, like the most of the inland ferry, like Aditya or any of the ferries operating, Aditya has 67% is from sun. This is a full year data, including monsoon, everything. So in that scenario, what happens is, when you do the cost with a 7 rupee electricity, you get a 9 odd rupees on the grid cost, and the solar is 67, means solar is free. So actually the cost of electricity is about 3 rupees. The energy from, in the case of Aditya. Whereas if you don't have a solar and the same boat is pure electric, this would have been closer to 10 rupees, like 10, 12 cents. And if it's a pure diesel, same Aditya, you put a diesel engine, it would have been a 40 cents. This is a cost of energy, what you get on a propulsion side. So this clearly shows, again, I'm saying in the slow speed. If Aditya type vessel has to run at 10 knots, then the solar percentage will drop from 67 to 20 odd. Then these numbers will converge closer. So this will still always be 12. This 4 may become 7 or 8. So it's very important to get that insight. That's why I just mentioned like that. Now, you can also have hybrid. When I say hybrid, it's like parallel or series. Series means you always, the motor is the only thing that connects to propeller. Parallel means engine also. That's only different. When we talk, I always give the advice that parallel is always cheaper than series. Both CAPEX and OPEX. The reason in OPEX is because in series hybrid, there is a double conversion. That is why series hybrid is more expensive from an OPEX angle. And series are always more expensive from capex because the motors are big and therefore the prices go up. So if you want hybrid and it works, parallel is the best. That is the only insight you can get from this when you do a parallel shift. So whatever I just told, I just summarized it as an initial conclusion using purely OPEX, right? So all what I told, I'm not going to read again, but this is the insight you get, those 5 points or 6 points you get. Now, obviously, when you say economics, it is not just OPEX that is important. You need to know CAPEX and the life cycle cost, right? So this is how you should do economic analysis. So, and the basis, some of these numbers are just based on the boats are in operation. We have about 31 boats now in operation, solar boats, different sizes, small to big, and different application, tourism. So using these data is what I'm making this statement, which is why I just want to set that context. So we will take the case where it's a 100-passenger ferry. Try the various speed combination, 8 to 12, and range. Range, I mean, how much kilometer you will run in a day. Aditya runs 66 kilometers. Most of the Kochi Metro boats run 60 to 70 kilometers. 100 is maximum. So 200 is applicable when the speeds are high. When you're 10, 12 knots, that is when you do 200. So if you put that same numbers, like these same numbers what I talked, this is a foundation for the costing. And how you do costing is what, again, you are not going to read through this, but the logic that you will factor in all the cost, capital cost. So there will be, for example, all the input costs. These are all inputs to this analysis. You will be able to read when you get the access to PPT. But the idea is you get all the input cost, both CAPEX and OPEX. You have all the cost. And then each scenarios are, I will do an LFP battery or an LTO battery. I will do LFP plus solar, LTO plus solar. I have hydrogen. I have a pure diesel engine. So these are some and I have fuel cell also. These are all the possibilities. You find the CAPEX and OPEX the same way I just discussed. I will just give you the insight, which is what is important today. Now, the way you do is TCO means total cost of ownership. So you take first year, second year, third year, 20 years. In case of battery, you have battery replacement, 7th year, 14th year. In case of LTO, it's a 10th year replacement. In the fuel cell, there is a replacement every few years, the fuel cell membrane, things like that. So you have to model all your costs, put it down. So it's not only the cost actually you put, you have to introduce the time value of money. So one important class you should carefully listen when you are still studying is your economics class, which we all ignore. Even I ignored when I was in engineering, but I'm just telling that's the most important class beyond your technical knowledge, because you need to model the real cost. So the 100 rupee you get 1 year later is not same as 100 rupee you get today. In India, inflation, government says it's 5%, it's closer to 10%, I would say. But the fact is, it is higher inflation. So naturally, cost of money is important. So that discount rate is what you need to model. And today, what we call as a net present value you have to do for all projects. That's what I meant. So if you put that model and put this, so you have a total cost of ownership, convert to net present value. This is total cost of ownership with net present value. Then you will know which is the most cheapest technology. And this is the only way to know, not like some arbitrary statements. This is the way to do. So one thing we should all remember is in any green technology, the initial cost is higher. The savings are more. That is the logic. All green technology has high CAPEX, low OPEX. So in that scenario, if the cost of money is high, which means your finance cost is high, that will always make it difficult for green technology, because you have a high initial cost and your future savings is less valuable when the cost of money is high. Which means in countries like India, where the finance cost is high, if I go to bank and borrow money for a project, it's mostly somewhere between 10 to 12%. It's on the high side. If I do the same thing in Europe maybe 4-5%. If I do in Japan, it may be 1-2%. So this is the number, which means in low discount or interest rate countries, it is easy to do green technology. That's the insight. So as the cost of money is higher, is more difficult for green technology adoption. So again, all this combination of speeds like 8 kilometers, 75 to 8 knots, 75 kilometers, 12 knots, 200 kilometers, all the combination, the total cost of ownership number is what is plotted. So this, if you plot, what you learn is, or the insight I want you to take is, always LFP plus solar is cheaper than LFP. LTO plus solar is cheaper than LTO. And what you can learn is always putting solar is better than pure electric. That is an important insight you should learn for you seeing this table. And another important insight using the same results is, as you move from low speed, low range to high speed, high range, something is happening to this graph. There is a switch happening. Here, LTO is more expensive than LFP. Here, LTO is cheaper than LFP. So somewhere here, the switch is happening. Somewhere like 10 knots, 150 kilometer, 12 knots, 100 kilometers. So this insight is what I was trying to convey when and I'm very vocal in the public domain. When I say that, when the public transport goes for LTO, you should have a scenario where the speeds are either high and the range is high. Otherwise, if you are investing in an expensive technology, it is not economical. So which is why when the Kochi Metro boat runs at 50 to 60 kilometers per day and about 8 knots, it should have been better to do at an LFP with half the cost. But that's my only submission, analyzing this graph. And so the natural question is, when does hydrogen work, right? So only when the range is high, the hydrogen works. At low speeds and range, it is again a bad idea to shift to hydrogen. So when you do that 12 knots, 200 kilometers, the hydrogen is cheaper, right? So when the range is high, hydrogen really works. And I just want to, when I say trip range, the special case is where the trip itself is very long, like from Ernakulam to Trivandrum, Ernakulam to Kozhikode. Such long range, when the speed is high, then the battery and all will not work because the battery size is super high. Then the better solution is go for hybrid, or when the hydrogen works, then go to hydrogen. So the insight I would say is, in 12 knots and 200 kilometers, the hydrogen starts becoming better than the battery because battery becomes super expensive. LTO goes over the roof because the range is, LTO works best when you have a short range, short trip range, you do frequent charge. That's really excellent technology there. And so this number I want to give is, when you go on a very large trip range means that 100 kilometer, even the hybrid, series hybrid and parallel hybrid, as you can see here, is even cheaper than even the hydrogen. So today, if you have to do shift to electric, go for hybrid for the very long range, and then eventually switch to hydrogen is what my submission is. So these are some of the insights I want to convey. So if you have any questions, we still have some 10 minutes, I think. If you have any questions?
Okay. Thank you, Sandit, for your exciting and interesting presentation on your topic. And we are open for the question and answer session. Before that, let me ask you a question.
Yeah.
Regarding the Aditya, have you got any feedback from the passengers who has got the feel of the economy and the comfort inside?
Okay. So in India, typically, so here I was always focusing on economics. And India only economics sells, right? So obviously none of you sitting here will buy anything just because it is green. I'm also like that. So let's given that is a fact, which is why I stress all about that. But this is very important, that green technologies, and Aditya as an example is suggested, has a much better experience for passengers. You can see the boat actually there, Aditya versus other boat. It's much more spacious. You don't have any smell of fuel, no sound. So much so that they now have a library in the boat now. There is a library Rotary has kept on the boat because it's silent. You read, you do your thing. This is possible in that boat versus any other boat. So this is, I would say, and this has been the feedback from many of the passengers. We have many of the feedback in terms of videos we have taken, so that when we were trying to sell the idea beyond Aditya, right? But now we don't have to do that in Kerala for sure, because it's already established. People know the benefit. So yeah, so that's Aditya.
Wonderful presentation, sir. You were putting a lot of comparative statements and the conclusions were made. My question is, if you see the grid charge, the cost of per unit of electricity is around 7 to 11 rupees, depending upon the rate of subsidy what you're getting from the government. But then my question is, we are professing the word sustainability all the in all the meetings and every this thing, but we are not considering anything regarding the type of electricity what you're receiving from the grid. For example, if you see in India, the 70 to 72%, if I'm correct, is from coal. The grid charging what you're doing is the electricity what is made from coal, and you're charging it and you're running the boat. But then obviously, when you compare, if you do a proper analysis, you will be able to see that if you do a grid charging, from the grid, in which the grid is getting supplied from coal, powered, power plants, you're going to have a lot of problem with your SOx. Your NOx can be controlled, obviously, but then your SOx values will shoot up like anything. So we are now professing the hydrogen fuel cell systems. We just want to plug in the other one to have a balance. But then, but rather than putting all our efforts to hydrogen, why can't we try to correct the root cause of the problem? Because you burn your coal and you produce electricity and you grid charge it, you're going to create a lot of emissions. In fact, but
Yeah.
nobody is discussing about that aspect. I don't know why.
So you have said 2 points, I would say. One is, unless the grid is clean, pure electric, when you say pure electric boat, is not going to save anything on a very high level, except for small things like noise. But broadly, it is still as polluting if your grid is 100% from coal, right? The second point is, why go to hydrogen and why not the cleaner grid as a thing? So let's discuss about the first one. Making the shift of the transport system to electric has to go in parallel to the shift of the grid from pure coal to cleaner. This has to go in parallel and simultaneously. It's not that you do this and then only you start. So, because many of the technology adoption takes time, right? So until you achieve the scale. So Aditya is now 8 years running. Now we have some 20, 30 boats coming every year. So maybe next year 100. But we are still very small percentage of the overall boat. Maybe 10, 20 years is when the grid also will be cleaner. Also relative to a location, like the number you told, 70, 75% in India, which means 25% is still grid, which is a positive part. You can look that way. It's better than 0%. But Kerala is closer to 50 because you have a lot of hydro, right? So what you do in Kerala energy is 50% grid. So in that sense, half of the energy you use from a electric boat is clean, half is not. So you have reduced your problem by half for sure. The other thing you can do is, which I am advocating, increase the solar contribution. So then you even reduce the dirty electricity, you can say that. The other thing is why hydrogen will be essential in certain application is because whatever you do the grid clean, in a transport system which is disconnected from the grid while moving, I'm saying boats, plane, train and car and other things, you still can connect to the grid by various technology while moving. Then you don't have to think hydrogen or anything. But for boats, ships, you still need some clean fuel once you are disconnected from the grid and then you're moving. Therefore, in such long range application for ships, you will still need hydrogen kind of fuel eventually. So both will be needed, I think.
Good afternoon. Thank you very much for all the insights into hybrid and electric propulsion. I'm Commander Makka from Navy. I had a query regarding have you all been involved in varying operating regime? Any study on that? Like
What
other
is-
than the fixed speed regime,
Ah.
if you have ever gone into varying operating regime ships, say auxiliary naval platforms, like offshore patrol vessels. I'm not talking of full-blown combatants where we don't have a fixed speed. So I can do a particular operation at a slow speed, then hybrid options. Is there any study relevant on that?
Yeah, to your, you're from the Southern Naval Command?
Yes, sir.
So you have some 87 patrol boats of the FC category, which are about 15 meter, 45 knots, those kind of vessels. So the study we did, I'll tell you, at least in summary, 95% of the time it's going at slow speed patrol mode, which is about 6 knots to 8 knots. And the rest, when you want to do a chase, you do that fast. So the water jets are designed for that high speed operation, 750 HP into 2, somewhere around that engines are there. The issue in those engines running in petrol mode, which is at 6 to 8 knots, is super inefficient to run those engines at that slow speed. So you end up consuming some double the power required than a independent smaller engine. So keeping this in mind, the clear solution for that is have a parallel hybrid. You have a battery electric for the slow speed mode. Even in by giving that number 8 hours. Finally, understanding is what is your energy need, right? So that is why speed and range I gave. The speed 6 knots, how many hours you run? Let's say 8 hours. Get the energy needed, and that you size your battery. Some proportion from the sun, because in petrol vessel solar contribution was like less than 10%. It was a small area only. With that, you size your battery, motors, which is totally independent of your diesel propulsion, which is needed in the high speed chase mode. The ROI, the economics, normally when I say public transport, ROI is 3 years. Aditya is 3-year break even. Like normal ferry is 2.2 crore, Aditya is 3 crore, 75 lakhs difference, you save 35,000 liters, which is like 35 lakhs, 3 year, 1 crore savings. So roughly 3 year is a savings number. In your petrol boat, it is less than a year. And the reason is because in the slow speed, it is operating a highly inefficient mode. Both the water jet efficiency as a propulsion and the diesel engine inefficiency are low. So the break even is less than a year. And of course, that proposal is there with your CNC or whatever. Maybe it takes its own time to do conversion. But that's one of the best example of retrofit possibility with a parallel hybrid. We have 4 minutes.
Lot of people in business misestimate it. They quote for something, then find out it is actually going to cost a lot more. But anyway, you are talking about two different ranges. So your the cutoff point between one and the other, maybe that's a little fussy, but if you're definitely deep down into one of those regions, we are very comfortable. I find that a lot of people don't make good economic decisions. They do not do economic calculations. They start a business without any estimate of. So I think that's a weakness in our country. Is a general comment. Thanks for your nice talk.
If you should see the DPR of Kochi Metro, Motor Metro, you have that answer. Anyway, so the point I said is with regards to the costing, I totally agree. For estimating the cost of new things is always difficult. You can never get it right. The example I taken is when I take 100 passenger ferry, the structure, everything else except the system is a known cost because there are so many projects. Like if you go and order a diesel ferry, for example, 100 packs, it's about 3 crore. Multiple, you quote for many things. It's a standard ferry public transport. If you come to me and ask for solar fare, I'll quote around 4 crore roughly. So I'm just giving you that number. This is based on just a system size of 2 into 40 kilowatt hour battery. When that speed and range increases, two things are happening. Instead of 40 into 2, I'll put 80 into 2 or 122. That is again very scalable in that steps. The batteries, that is the only thing changing. Nothing else is changing in the board. The battery has scaled up slightly higher. The motor, maybe if the speed changes, the motor instead of 2 into 20, it may become 2 into 30 or 2 into 40. There are some steps like this. Keeping that, and which is why I give the caveat that these are the boards we have done. These numbers are based on that. I have not done fuel cell. I have taken public information from CSL number on the fuel cell. I have the quote for fuel cell, like a 70 kilowatt fuel cell is about 2 crore. It's a known number. The actual fuel cell board cost is 18 crore. That's also known number. so whatever is known, I've tried to do on that limit. If it's an arbitrary project, I totally agree with you. The numbers may be really off. But there are so many examples of this 100 passenger ferry that the cost, the uncertainty is in the operating cost. And there I have used the experience of Aditya numbers because we have the IoT and data analytics on the energy consumption, solar production. Hence, we get a reasonable accuracy on the OPEX. OPEX is always, again, tricky to estimate. Okay. Right. Okay, thank you very much.
Thank you, sir, for an insightful talk. Your prolific expertise and contributions have greatly enriched this section. I now invite our session chair, Professor Dr. A. Mathiyaragan, to kindly present a token of appreciation and certificate to Sri Sandeep Tandashiri. Sir, please.
So we'll move on to the next presentation. The next speaker is our own Professor Dr. D. Ebenezer is currently working as adjunct faculty member in the Department of Ship Technology, Kochi University of Science and Technology. He holds a PhD in ocean engineering and MS in ocean engineering from University of Rhode Island. He has also completed his PhD BTech from Naval Architecture from Indian Institute of Technology, IIT Madras. Before joining this department as faculty member, He was working as an outstanding scientist in NPOIL, and his research interest includes computational fluid dynamics, analysis and design of ships, underwater electroacoustics, sonar, sonar and marine propulsion, and he has received various awards for his immense contribution in the field of hydrodynamics. In addition to the academic associate editor of Journal of Acoustic Society since 2012, and he has been the chairman of Hydro Vibro Acoustics panel at the Naval Research Board. Students project funding agencies. So with this brief introduction, I welcome and I'll invite Vinay sir. Over to you, sir.
Thank you, sir. Thank you very much. My pleasure to be here. Okay. So the talk today is titled Computational Ship Hydrodynamics, but it's not a kind of talk that I would normally give in a classroom. You've been listening to talks from people in the industry, and all the students appreciate that they are somehow different. Some industry people have been advising our department that we ought to teach them a variety of things, including economics and many other things. And so, anyway, it is Golden Jubilee time, and very few of you have the privilege of thinking back about your 50 years of life because you are not at 50 years old. But a few of us who have crossed 50 can think of how we were when we were students and what we have learned in the days since then and how life has been. So, with a slightly philosophical thinking, I will continue my talk. Okay. The first thing that I would like to emphasize is that computational fluid dynamics, or more specifically computational ship hydrodynamics, is really part of a big ecosystem. Very often, if you listen to students who are doing MTech or BTech, they are very focused on their particular task at hand, and they cannot think beyond that task. So in that particular sense, our BTech project where you are asked to design an entire ship is a very good experience because you have to balance many things. So how big should your picture be? So my thinking is that at least you should think that you are part of a ship design and construction team as shown here in the slide. So at the top, we have a ship design and construction and block. Unfortunately, what happens is that there are very few institutions where both design and construction is done. If you look at our very big shipyards, they do not do their own design. They outsource most of their design and they are focused on construction. Construction may actually cost 90% of the whole thing. Therefore, it makes sense for them to focus on construction and outsource the design. But I put in another item there called finance, not knowing that Sandit will talk a lot about economics, but that is actually the driver. Nothing happens anywhere unless it is more economical, unless it is cheaper, unless you are very rich or government is funding you and forcing you to go in a particular direction. Finally, it is all finance that decides whether a particular choice is made or not. If you come down further from that, there are many other verticals, and design is only one of the verticals. So within construction, there will be many other verticals. And within design itself, you will have, in our department, we talk about structures, we talk about hydrodynamics. So hydrodynamics is only one part of it. And we say, oh, within hydrodynamics, you've got experimental hydrodynamics, computational fluid dynamics. So again, there is a breakdown. So the first thing that you ought to realize as a student is that you're working on one small part of a very big problem. And we're not asking you to become experts in that entire problem now, but just to be aware that you are part of one big problem. You are solving one part of a very big problem. And sometimes your solution to the problem may not be accepted, and some other solution would be accepted. And that you will learn to appreciate in the days to come, especially after you join an organization. But these days, I find that many of our graduates who go and join organizations, in those organizations also, they've got blindfolds and they are asked to do one particular job for this week. At the end of that week, that job is over, to move to the next job. It is not very clear to me that they are able to build on their experience. What I did last week and last year, am I building on that when I am working now? Unless you are able to do that, you will not become a true expert. When I joined NPL, some people used to come and tell me, I have 20 years experience at NPL. And then I would talk with them to understand what they know, compare that with what I know. I sometimes would come to the conclusion they had 1 year experience 20 times. They don't have 20 years experience. Whatever they did in their first year, similar thing they've been doing for 20 years. So they have only, at the end of 20 years, effectively they have only 1 year experience. So this is something you need to look out for. You need to ask yourself, what is it that I have learned new in the last 1 year? What is it that I can do now that I could not do last year? And that needs to be asked by everybody, not just students, but also by faculty and the people in the industry, etc. Okay. Okay. So that's the background. Let's see. So this is an outline of my talk. We have an introduction. Then I'll talk about, since our topic is ship aerodynamics, I'll mention a few workshops that have been conducted. Then again, we're going to start talking broadly about aerodynamics of ships, come to resistance of ships. When we talk about ship aerodynamics, it's not merely resistance. There are a lot of other things that are of interest to us. So we'll talk about that. Two benchmark ships that we have worked with. I'll show you some results. Conclusions. I forgot to add conclusions at the end of that. Okay. Okay. What is computational ship aerodynamics? So, as Sandit explained, what is a boat, a small ship, large ship. So what is computational ship aerodynamics? For many people, it is only some very narrow part. But actually, I'm using this term in a very broad sense. Primarily, we are going to talk about ships at a air-water interface. Later on, I'll mention submarines and why submarines are really much easier to deal with. We are also talking about incompressible but viscous water. We are talking about ships. They're not going at very high speeds. The Mach number is low, so I don't have to worry about the compressibility of water. But I must account for the viscosity of water. Okay, so that's an important part. What is computational ship aerodynamics? It's a numerical method. It's a numerical method of finding some things of interest to me. Actually, you are always driven by what is of interest to you. How exactly you find it is not very important. So if you may use computational ship aerodynamics, if you had other facilities in your institution where you could do experimental aerodynamics, you would do that. And depending on your expertise in one area or the other, you may choose some particular thing. So if you recall conversations, discussions in DIMS, for example, Those who have experimental facilities will swear by that. They say that is the way to go. Whereas those who have computational facilities will say this is the way to go. And if you put them both together, they will try to come to some agreement on, oh, you are also fine, I'm also fine, we are both okay. Okay, but computational ship aerodynamics, as I see it in the future, just because of cost, because of economics, we are going to do a lot of things with computational ship aerodynamics. You know that new aircraft are being designed and flown without extensive experimental aerodynamics. Full-scale aircraft are being designed and flown based on computational aerodynamics. So if they can do that, why can't the ship people do that? Okay. So within computational ship hydrodynamics, I've got a resistance. So that's the things we usually first talk about. I always encourage our students, you ought to start at the last rung. Do not try to start somewhere in between. People in the industry will tell you the way to learn to swim is throw you into the swimming pool. I don't agree with that. Start with the basic things. Learn that well. Master that. Then move on. It'll take a little time in your initial first year and second year to do that. But if you do that, later on in life, you are well settled. Whereas if you fail to pay attention to all the basics, you will pay the price for that later on. Okay. So resistance is a basic thing. We ought to get that right. If you can't get your resistance right, don't start looking for the other things. What else would you be interested in? Okay, we are interested in, if I look at that picture, oh, I can see a battle carrier group going. I can see the waves on the surface, Kelvin wake. Oh, I'm not interested only in the resistance. I would also like to know how the waves are generated on the surface, what exactly that pattern is, etc. Well, you always want to stop and think, why do I want to know that? How is that going to be useful to me? In an academic setting like ours, we may tell you, look at that also. There are people in industry who are not bothered about that. They say, I only want to know what affects me. What's happening in the water, not of interest to me. Oh, but we know that what is happening in the water affects your resistance. So you may not need to know the Kelvin wake and its details at a great level of detail, but you need to know something about it. Okay. So velocity and pressure fields, especially those around my ship, are very important. And the stress and the pressure on the hull is important. Okay. 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 Another thing that I want to mention here is that the last point says results of many analyses are used to design. So these days I see many papers titled design and analysis of something. Oh, no. What they actually mean there is some preliminary design followed by analysis, which is then followed by the real detail, the final design. When I think of design, I mean, you have frozen all your dimensions, you have chosen whatever you need to do. So that comes typically for me at the end of 100 analysis. You analyze 100 structures or 100 ships or 100 sonar transducers. And at the end of it, you say, oh, this is what I'm going to prototype or this is what I'm going to manufacture. So results of many analysis are used to design. Okay. And what is another way to answer this question? What is computational ship aerodynamics? One of many aids used by ship designers. So we ought to think of ourselves as quite important, but remember that always remember that we are only one part of the big design process. Oh, you heard this word design a lot. All our final year projects are design of something. And people say, I designed something. So I ask generally, what is a design? So this is something that I have coined, started using at NPUL the last 5 years of my stay there. It's a solution to a constrained optimization problem. Design is a solution to a constrained optimization problem. Okay, some couple of keywords there. Of course, one is optimization. And I put a footnote there. It is not merely a solution that meets requirements. in the ship design process, we start with some owner's requirements and offering a design that meets the owner requirements, or offering something that meets the owner requirements, I don't call it design. It's a design only when it is optimized. Optimized in what sense? Okay, you decide. But when you say you have designed something, you should also be able to tell in what sense it is the best. It has to be the best in some sense. Only then does it qualify to be a design. Okay, so the design is a solution to a constraint optimization problem. What is a constraint? Many a time it may be the size of the boat that you want to design. It may be the cost of the, it may be capital cost, it may be total cost, but you need the diameter of your propeller cannot exceed so much. What is the best propeller that you can make? So you need to specify the function that you're optimizing, function that you're maximizing, as well as all the constraints before you start the problem. Your statement of the problem has to be very clear. If the statement of the problem is not clear, you will not know whether you got a solution to the problem. So before you start doing your project work, please write a statement of what problem you're solving. At the end, if somebody wants to contest that, they will contest that. They will not contest the statement at the end of 1 year or at the end of your MTech or PhD. Okay. When we say optimization in ship design, we could start with something very small. We could start, for example, I want to design a hull whose resistance I want to minimize. I didn't know Sandit was going to talk about these things, but he usually does. So what is the total cost, capital expenditure, divided by deadweight ton? It's not just capital expenditure. This is the deadweight I want to carry, and I can do that in so many tons I can carry. So what is the total cost of the ship? Or maybe you want to talk about transport cost, or best, as Sandit often presents, what is the lifetime cost? So as you grow, as you become progress up your organization, you need to think about these things. But for the present, we'll talk about resistance. Okay. I've shown this slide in a couple of my classes. Some of the BTech students also have seen this. This is to introduce you to system analysis. In our BTech classes, we have one class on resistance, another class on propulsion, and there's some amount of overlap where we try to tell you towards the end of the semester how to put these things together. But even for a ship, I need to think of it as an engine, a propeller, a ship. I can optimize my ship. I can reduce the resistance of my ship. But that may or will seldom be the optimal solution for my entire system. My system is the whole thing. You may optimize the resistance and give me no space to fit a propeller. So that's not necessarily the best ship. Okay. So again, that footnote is very important. It says assembling the best subsystems does not yield the best system. Very important. Every subsystem in your system could be the best from some criteria that you have evolved. Okay, if you look at this whole system, input is fuel, output is speed. Okay, so output by input is what I want to optimize. Okay, maybe I want a particular speed. Okay. But if you can optimize your ship alone, optimize your propeller alone, come and fit them together and they won't work well. So you need to consider the entire system, especially if one of them serves as a load and the other one is driving it. Okay, so propeller serves as a load for the engine is driving the propeller, propeller is trying to provide thrust for the ship. So we need to think of this as a whole. Yeah. So actually, want to give you some background that there's a lot of work going on in the last 40 years, 50 years on ship hydrodynamics, and workshops are being held periodically at the world level. India has not participated in these workshops in a big way, but there are numerous organizations in the world which are regularly participating in this. So yeah, it started in 1980, and the last one which was held was 2015, and the next one which is going to be held is in 2025. Okay, so in 2015, we did not have fantastic computing facilities. So most of the workshops were based on, can I find or analyze my ship hydrodynamics very well for models? The model sizes were 7 meters, sometimes 2 meters, but the emphasis was never on the full scale ship. But now we know that scaling up from model scale to full scale has got its own problems. So the question is, can you model a full scale ship? Not a model, but a full scale. I know that some of our MTech students are modeling full scale ships from a structural analysis viewpoint. Yeah, that's another thing that in our department, we need to bring together these two things so that the department becomes a ship design agency, in which the department will do both the hydrodynamics as well as the structural analysis. In the early stages, we can build these two separately. We can have a structures group which is becoming expert. We can have a hydrodynamics group which is becoming expert. But after a few years, these two need to join so that we become a ship design agency. Well, if you're going to do computational ship hydrodynamics, you first need to know ship hydrodynamics. Before you start doing computational ship hydrodynamics, you need a good understanding of ship hydrodynamics. Okay, so here's a big block diagram of what it involves. On the left side, we've got inviscid flow, right? And below that, on the right side, we've got viscid flow, viscosity is included. Then I've got deeply submerged, and I've got ships at a air-water interface. Okay. So this interesting thing which you studied in your BTech, D'Alembert's paradox, no forces act on a deeply submerged body, moving at constant velocity in a straight line, zero resistance. That may come as a surprise to some. If you think of it that I don't need any power to move this body. So the point is, viscosity is so important. Viscosity is so important because that is what is exerting a force on my vehicle. That is why I have resistance. But very interestingly, in the left side, if you look at the inviscid side, if you bring your vehicle to a air-water interface and you still think that there is no viscosity, now you've got resistance. So D'Alembert's paradox is only applicable to deeply submerged bodies. Okay. So when I come to the air-water interface, even without viscosity, I'm going to face resistance. What's the implication of this? We'll see. Okay. So from there, we move to resistance of ships. Yeah. Okay. Again, we need to understand this before we go into computational ship hydrodynamics. So this word taxonomy is something which I encountered after many years, after coming to QSAT, because in our syllabus it says that you ought to need your questions should be set at different levels of difficulty. Okay, fine. So we have taxonomy. So taxonomy is a systematic way of breaking up something such that there is no overlap. Okay, such that there is no overlap, so that they are disjoint sets. Okay, so when we want to think about it like that, then there are maybe a couple of ways of doing about it. I think about the total forces acting on my ship. Then I think about the forces could be normal forces, so we call them pressure forces, or they could be tangential forces. Okay, so the distinction is very clear, either it's normal or tangential. And very interestingly, these are the only two forces which act on my ship. There is nothing else. Even if it is at an air-water interface, all the forces which are acting on my ship can be broken up like this. So if I want to find the total resistance of a ship, I can always compute the pressure forces separately and the friction forces separately, and I can add them and I will get the total resistance. But there's another way of thinking about resistance. So you see, in this way of thinking about resistance, you don't have to worry about or ask what is happening at the surface of the water or anywhere else away from the surface of the ship. Only what is on the surface, acting on the surface of the ship, will affect the resistance of the ship. But there is an alternative way of thinking about it. That is to say, how much energy is transferred to the water. Okay, this is from Molland. This picture is from Molland. I've added some comments to that. How much energy am I transferring to the water? So as a BTech student, I was taught how to measure surface displacement and use that to compute resistance. Because if you want to measure something that is happening on the surface of your hull, that can be very difficult. So this idea of let's use the energy that is transferred to the water because that is the amount of energy that I have to expend to move my ship. Oh, then I will be able to find out what is the total energy transfer. So these are complementary ways of finding the resistance of the ship. But sometimes you want to put your foot into both. You want to know what is the pressure, you want to know what is the tangential stress, but you also want to know what is the surface displacement. Okay. Here's a very nice picture. This is from Burke. I've shown it in some of the classes. It's very nice because we want to be able to break up our total resistance. On the right side here, you can see that the resistance of a ship is shown there. The Reynolds number is approximately 1E9. And the resistance of the ship has a few components. See, this dash dot line is actually my ITTC 1957 model ship correlation line. Very simple equation. You can find out what this coefficient of frictional resistance is, and you can draw this dash dot line at whatever your ship Reynolds number is. And the total resistance is shown by these X marks. That includes the wave resistance, which is actually shown here, and this thick black line, which is a continuous line, that includes the form factor. This 1957 model ship correlation line doesn't account for the shape of the ship. It's for a plank of wood. But the black line accounts for the shape of the ship. So if you have different ships, then you'll have different black lines, but all of them operating at this Reynolds number will use the same ITTC line. So the very interesting thing about this is you don't have to do a lot of experiments. You simply need to know what your Reynolds number is, and you can get a rough estimate of what the coefficient of resistance is going to be. And using that, you can find the resistance of the ship. If you can find the resistance or estimate the resistance of that ship so easily, why are you spending all this time and money doing computational ship aerodynamics to find this? Well, the answer is our economics is always 1 or 2%. If you go to a big place where they are buying something, they will bargain and ask you to reduce your price by 1% or 2%. 1% or 2% will be tens of crores. Okay, and then you want to get that order, so you agree for that. You agree to give. Some people we get 10% reduction from people. They will take the order, and afterwards they will find that they cannot deliver at this price. It is going to cost them a lot more because they were not able to correctly estimate the cost of building something. They took the order. When they actually did it, they find it is costing more. Some of them will do something and deliver it. Others will give us a lot of trouble. But anyway, price is agreed upon before we place order. Acceptance test procedure is agreed upon before I place the order. Only if you meet my acceptance test procedure will I accept it. Otherwise, you forfeit all your money. You spent 300 crores and don't get anything from me. Okay. So it's a very tough world. Student life, very comfortable. Okay. Okay. So this is a very important thing. See, there is a lot of information available in the world. Whether you understand it, whether you digest it, whether you can use it, that is the key point. Right? Internet has got everything. How do you know how to use it? That's the key point. Okay. So this is from an excellent book by Larson and Raven. And they have shown the breakup of resistance of a few types of ships. I know you can't read the small text, but okay. So this is for a tanker. Okay. And the next one is for a container ship. And the next one is for a fishing vessel. So what I want you to look at is this line. This line is showing what percentage of the total resistance is due merely to the ITTC line. So for a tanker, 65% of the total resistance is from ITTC line. Don't have to do much. If you come to a fishing vessel, only 25% is from the ITTC. So actually, it is much harder to design a good fishing vessel than it is to design a good tanker. Okay. So where does much of the resistance for a fishing vessel come from? 57.5% is coming from wave resistance for a fishing vessel. And there are people in our country and elsewhere who are very good at optimizing the wave resistance. So you give them a ship, you give them a hull, they will change a few things here and there, and they will reduce the total resistance. If you want, you can do an experiment and see, or do a CFD and see. But the point I'm making is that fishing vessels, there is a lot of space there for you to optimize. Okay. So in the near future, we are planning to get into this optimization in a deep way. We are planning to do optimization of some displacement vessels, maybe a tanker or a container ship, but we are also planning to do fishing vessels. So we'll see how it progresses. Okay. Now the resistance is the easiest thing to compute, and why? Because it's an integral over the surface. And you, as everybody knows, if your integrands can be terribly off, but your integrals will be right. So resistance we can often get with low percentage errors, and we can estimate resistance quite accurately. But a difference of 2% in resistance, 2% in fuel cost, and your whole equation for the economics may change. And your decision, more than that, when you are comparing two different hulls and you want to decide which one to choose, if you don't do it accurately, you will choose the wrong one and you will end up with 2% more resistance and therefore the cost. Okay. Okay. And yeah, but even resistance is not so simple to estimate. Every ship has got regions with adverse pressure gradient in the stern sector. And people in the industry are always using this K epsilon turbulence model because it is cheaper to run in terms of computation time. And that is not capable of modeling the flow in the stern sector. So definitely your errors with the K epsilon model are going to be high, and you should use a better model. Okay, so we never use the K epsilon in our Chase lab. We've always been working with K omega, which is much better. Okay. So here we are showing some towing tank results, again little bit small, the people at the back cannot see. But what I want to emphasize in this is, just to mention, is that in addition to doing the resistance test, people are doing towing tank tests where they measure the sinkage and the trim. That's all that I would like to mention at this point. There are two different organizations, both in Japan. Both have done measurements, but you can find that after they do the measurements, that their measured values are not exactly the same. There's a difference. So, which I want to emphasize to both the experimentalists and the computational people. Both groups often think that an experiment is always correct. And I know from experience that it is very easy to bungle an experiment and get crazy answers. And that is what you will get most of the time. It is to get good experimental results, you need a very good facility and expert people. That combination is not easily available. Okay. What are the other functions and fields of interest? Okay, now there's a ITTC International Towing Tank Conference, and you can see that this document is 2024. Now these days they've started advising users on how to do everything, on how to do experimental ship aerodynamics work, how to do computational ship aerodynamics work. So all these documents are there. Won't go into the details, but if you want to find the calm water resistance, if you want to find open water propeller characteristics, so calm water self-propulsion point, hydrodynamic coefficients, for all these things, ITTC has got recommendations. So everybody should be able to do that, read that and do it. But what's the problem? Why are they not all getting the same answers? Oh, we don't have good computational facilities. So everybody is trying to make do with whatever facilities they have. Some people have excellent facilities, but they're not using it very smartly. You can see that because their results are not the same as those of others. Okay. I want to talk a little bit about two benchmark ships because everybody in the world is doing this. The world has come together and said, we'll give you benchmark ships and all of you compute whatever you want to compute, resistance, your wake field, etc. for these particular ships. Let us all come together and compare the results. That is what is happening in the aerodynamics workshops. So I'm going to mention these two things because we are using these two in our chase lab. This is a Japan bulk carrier lines. You can just take a look at that. This is a Crisco container ship. Yeah. There's one thing that I wanted to mention in this table, which is hard to see. Yeah. Okay, I didn't put that. Okay. Yeah. Yeah, here. It is in this table. Okay. You know, I've been telling in the stability classes that the most of the accidents which happen at sea are container ships, right? So this caught my attention. Look at this Japan bulk carrier. It's got a GM of 5.3 meters. Its length is 280 meters. This container ship length is 230 meters. Container ship has got a GM of 0.6. It's kind of hidden there, but the value for the container ship GM is only 0.6, whereas it is 5.3 for the bulk carrier. Okay. So different people have come together and presented these results. So we are learning from them. We are also making our original contributions to this. Shruti has been working on the JBC, and this is the mesh that we use. You can see that it follows the Kelvin wake pattern, so that we don't mesh unnecessarily places that do not have high gradients. Only regions with high gradients are meshed finely. Okay. This is a very interesting plot. You will find very few publications are showing all the details. They don't dare to show all the details. That is why. Here's a plot of resistance versus iteration number. And you can see how neatly, nicely our resistance is converging to a particular value. Still, there are oscillations because of the way the iteration is happening. There will be oscillations. But all said and done, if your mesh is good, you will be able to get a convergence like this. If your mesh is not good, you will not be able to get a good convergence. This based on our experience, is an excellent value. Here we are showing you some results for different meshes. A is the thickness of our wall adjacent layer. It's in microns. It's going from 129 all the way down to 45 microns. And here are some statistics which again people don't talk about. This is a normalized value of this A. And now we want this value of y wall plus to be small. People tell you what is their goal or target for this y wall plus. They never tell you what they actually got. So for us, always 95% and approximately of our y wall plus values are less than 5, which is great. And with that, we get very good values of resistance. Here you can see that our base mesh gave us some value of resistance, coefficient of resistance, and our ultra fine is this, which is very close to the experimental value. I'm just saying, can't go into all the details, just telling you that we've developed very nice systematic way of meshing the ship so that we can get very accurate results. Here's the surface elevation for that ship.
Sir, 5 minutes.
Yes. Okay. So this is a Crisso container ship. We have open foam in our lab, and we have got computers that with 128 GB of RAM. We have also got star cesium in our lab running on computers with 16 GB of RAM. So if you're smart, you will know how to use whatever resources you have in a good way. You cannot always keep saying, I wish I had 1 crore more money or this much computer, then I will work wonders. No. You need to work wonders with whatever you've got. After you've done that, you can go to your next level. So here are some results obtained using star cesium and using our 16 GB RAM results. In this case, some of you will know there's a tutorial in star, so we followed this tutorial. Whereas, so in this case, we allow the ship to pitch as well as trim. So the ship is not fixed; it's moving forward, but it's also allowed to pitch. It's also allowed to trim. So this problem is a little harder to solve, but it's done with less than about 2 million cells is what we used for a fine mesh. We've done this for various Froude numbers, and look at the median value of y wall plus, all under 5. Okay, and the percentage of P5 is the percentage of cells with a y wall plus less than 5. So 90 plus or 85 percent of our cells have excellent value of y wall plus. Okay. And some cells have high values of y wall plus. So that is indicated here. Okay. We can measure sinkage and trim. We are comparing our values with those found in the experiment. I mentioned that K epsilon is what industry is always using, but K omega is better. These are things that are difficult to measure. Okay. But we are doing it with K omega. It's almost at the end. This is a surface elevation. This is a surface elevation for the JBC, Japan bulk carrier. People have done experiments and they find out what is the surface elevation on the hull, on the center line of the hull. Therefore, you don't have many measurement points here. If you move away from the ship a little bit, then you can measure these points very nicely, and they have a large number of points. We've compared our results with these points as well, and it's in good agreement. Okay, I want to conclude where I started. I want to conclude by saying that at this stage of your life, the student needs to get expertise in whatever you're doing, but you need to be aware that you're part of a big organization, that you have to fit into the whole thing, And if you don't think of yourself as a structural analyst or a computational fluid dynamist, think of yourself as somebody who's doing ship design and construction. Okay. More definite conclusions. We got our level of expertise in computational fluid and ship hydrodynamics has increased greatly in Chase in recent years. All credit goes to our students because they have executed all the ideas. They have tried many different things, and they have helped us to understand how to do things well and how to do things right. Mesh generation is both an art and a science. Excellent meshes that meet tight specifications are generated by our students in both OpenFOAM and StarCCM. And you, in all these cases, you just have to tell them, hey, this is important, do it. And they find a way to do it. So it's just your need to recognize what is important. Convergence of results depends a lot on the mesh quality. If you have a good mesh, good convergence will be obtained every run. Okay, we've done commercial jobs using OpenFOAM at very competitive rates. So private company comes to us and says, you do CFD for me, this for me, and we've done it. And our rates are low and we have done it in a short time. So they come back to us again. A new 40 lakh CFD project. A new 40 lakh CFD project has been approved by the CMD of CSL. We are expecting that order to be given to us soon. Project will start soon. We are planning to buy ShipFlow. ShipFlow is in use in IIT Kharagpur, for example. It's a good but very costly computational fluid dynamics package. We are getting an educational institution part of it, and that will be there. Okay. So there will be high demand for CFD specialists when the India Maritime Center becomes functional. Yeah. So this is something that is going to that is already on the cards. India is planning to design and build more ships. So there will be higher demand for our graduates. I hope to see you all very soon in very high positions. Thank you very much.
Thank you, sir, for your excellent motivational speech for our students, for both BTech and MTech students. And as you really pointed out regarding the design and structural and hydrodynamics aspects. So what way you can advise or give suggestion for students project here?
Yeah.
Students project here so that they can improve their quality of projects, because they have been doing this project for last 50 years. Same design. Only the name of the ships are varying, but what is the innovation? It is there in the project. Can you suggest something?
Okay. 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 This question is okay regarding the BTech projects and how they can be made better. Okay. When we want to publish something, we have to do a literature review. So I asked our BTech students whom I have taught, they are now in the final year, have you, you're going to design a tanker. Do you have the project reports of some seniors who have also done tankers with you? So the first thing we tell them in our first review meeting of their project, we ask them, hey, what did your five seniors do? And they are supposed to first digest what their seniors have done before they embark on their own work. We have to build on what we already have. I think we need to put more emphasis on that. After that, after they say the five seniors did this, then we ask them, oh, you have to do something new. Show me what you're planning to do new. So only when the demand is there will they do it. So it is up to us to make that demand.
Questions from audience?
So
So I have a question. Is ship technology department is doing any basic course on CFD to students from other institution?
Yes. The School of Engineering offered one course last year on CFD, which many of our master's students attended. It was mostly application oriented.
Okay.
Not much on theory. So we tell our students to attend NPTEL courses on CFD. Some of them are very theory oriented and quite hard. We need a course somewhere in between. And we are trying to make one, we are doing one like that for our PhD scholars. So, yeah. So mix of theory and practice.
Any more questions, please, from students?
Okay. Thank you.
Thank you, sir.
Thank you very much.
Thank you, sir, for that enlightenment talk. Your valuable insights and expertise have truly enriched the session. I would now like to invite our session chair, Professor Dr. A. Madhiragan, to present a token of appreciation and a certificate to Dr. D.D. Ebenezer. Sir, please.
So the last presentation is now by Sri Anil Jacob. He is going to speak on energy efficiency and sustainable of marine vessels. Anil Jacob is the managing director of Ocean Opt, and he is a solution provider of marine industries. And he has worked in various marine related vessels, over 650 vessels under the various agencies. And he is a member of the Marine Engineering Society of different countries. With the small introduction, I welcome and invite Anil Jacob.
Thank you, sir. Thank you for the warm introduction. And also was listening to Sandit and Dr. Ebenezer on the various aspects of ship technology. I was just noting down also the good definition that Dr. Ebenezer gave for design, which is a solution to a constrained optimization problem. Very good, because we just talk about solutions and problems which we are finding out on solutions, but a constrained optimization problem and finding the solution is what really caught my attention. This is the same kind of solution that we do for our clients. So I'll just give you a little more elaborate introduction of myself so that you'll understand from where I come from, and I might not go into the details of ship technology or ship design in general, but I am more of an operational guy. My friends are also sitting here, so they really know my background. So I have sailed for 17 years out at sea before coming ashore, and I have taken a role with energy efficiency and vessel performance. And that's why I am also forced into, in a way, let's say, on decarbonization and sustainability and energy efficiency. Now that's kind of the norm in shipping. So I'll try to throw light on how this is kind of taken up on the modern vessels and what generally in the let's say, international marine fleet, the ship owners, the charterers, and the ship managers are viewing this, including the challenges and the proposed solutions. So that's where I will touch upon. So it might be interesting to a few, but not might be that interesting to the rest of you. But yeah, my efforts will still be there in trying to give you a good picture. So I'll cover up what I understand from sustainability. So any company which is looking at sustainability must look at my company is operating now. Would it still operate in 2050? So that's the first question that should cross the company. So that's why we say that you do your business, but at the same time, what is to be retained for the future generation is what we in simple terms say sustainability. And so when it comes to the marine aspect, this is what we look at. That in the long term, how are we kind of finding a solution to the environment? How do we still sustain our business, but at the same time look at environment as such? And also other two international rules and regulations. So you have an ethical code of running your business. And that's what I'm going to touch upon on one practically it's there. According to us, when you look at sustainability, you have to look at energy efficiency. You have to look at ESG, as we call as environment, social and governance part. So when you look at energy management or energy efficiency, there's a standard. It's a voluntary standard as of now, which is called as ISO 50K. This is what is being implemented in most of the shipping companies. We are also part of the team which implemented ISO 50K in our ship management company, which is Bernard Schulte Ship Management. By the way, just to let you know, I am also the head of fleet performance with Bernard Schulte Ship Management. And for most of our clients, we have these business units running around the world. So ISO being that voluntary standard, ISO 50K basically looks at how you can manage energy efficiency. So when it comes to vessels, you look at what are the main sources of energy and how you can manage it in a very optimized way. So that's what basically ISO 50K looks at. So when you're looking at energy efficiency, that's the standard that most of the companies follow. Then on environment management, you have what is called as the ISO 14K. Then we have also, I put ISO 27K here because that's for cyber security and data management. That's where I'm going to focus more on later on. Because we see a lot of companies with a lot of business, let's say potential. But to understand one's business and really put the numbers, you must have good quality data. And at the end of the day, how you really define one company to another company is what I've just mentioned, which is, are you really churning out a proper annual report, which could also be called as a sustainability report? So I would just coin everything into one thing, which is commitment. And commitment defines everything. Are you committed to sustainability? Are you committed to energy efficiency? It comes from the top. And I think that's why you basically define sustainability not just as environment. You put in the social and the governance aspect, because you need leaders on top who can envision things, who can actually give the path for the executioners or the middle managers who can actually take the company to full sustainability. So that's why I've mentioned that when you look at companies, when you want to join companies, please always search what is the leadership doing, what are their projects, read their sustainability reports, read their annual reports to understand whether it's a thought leadership that they have. And so you have a chief sustainability officer. Now you must also have a chief digital officer, because most of the systems are not even digitalized. So you must ensure that there is a digital transformation in place. And we all know that before we talk about digital transformation, first is digitization, then is digitalization, and then is digital transformation. So the entire path has to also be taken by the leadership. And then is the performance and the decarbonization. So generally we started with performance. When I moved ashore, I started with performance, but I did not know what is the bigger scope of all this. The bigger scope is sustainability. The bigger scope is how do you retain your business? And that's why I've put performance or decarbonization, because I feel that is secondary to the major aspect of how companies should run. We must have good companies, because that helps in business, that helps in economics, and through them only we can run a good, let's say, energy efficiency or environment or whatever we talk about. And important thing which we are now working on is to ensure that we have a proper automated software for an ESG compliance. Because we see a lot of companies, they are all into everything, but they lack a vision. They lack, let's say, a roadmap on how they are going to ensure these kind of roles come in that company. So this is what I just covered, which is the environmental, social, and governance aspect. I'm telling this because maybe in 5 years or 10 years, this is what could be the norm. And this will be the norm in shipping industry. Because every company will have these important 3 aspects to cover in case they want to really look at sustainability. Because the topic is sustainability, that's why I'm mentioning this. I'll not go into the details there. But what is OceanUp doing? So our company is an emissions management company. When we say emissions management, it's a combination of data management and compliance management. So you know that vessels report data. It's with that data that we run these numbers. And that numbers give us how much of CO2 is emitted into the atmosphere. It has got a technical as well as a commercial angle to it. And that's where we provide our services. So if you see, 3 important aspects is, one is data management, one is compliance management, and one is emissions management. Some of the terms you might be familiar with, but IMO DCS is the one from IMO for the data collection and submission. The same thing when it comes to European Union is called as EUMRV. We also have the sensor data, which is also kind of forming the norm in shipping. And in compliance management, where you come into the administrative legal process, like the EU ETS system, for which you have the emissions management systems in place. EU ETS, we have already talked about EXI and CII. Now you have a new regulation which is coming in, which is called as Fuel EU. And then also in 2027, with most probability, we will also have an IMO midterm measures also coming in. So this is where the international shipping is headed to. So when we look at IMO defining that it's going to make the, let's say, the world carbon neutral by 2050, there are a lot of questions arising whether this is really possible, whether we will reach that in 2030 is the bigger question now. But we, as a company which is providing services, we leave that thought to let's say, bigger people. For us, it's compliance. We help companies compliant with whatever is regulated. And it's a sad fact that although shipping is emitting only 3% of the world emissions, because we are a very regulated, industry, people push us to do the best. As a seafarer also, I had the same problem, that people ashore were making everything, in theory, but to put it in practice, we were having a lot of difficulty. So it's the same thing with shipping, and when you compare to other. So the reduction of GHG is what basically we look at. Important 3 greenhouse gases we have around us. And I have just put in detail on how basically from now till 2050, we are looking at decarbonization. So I think these rules and regulations you are already aware. I'll share the PPT, but I think that's more of something which will not be in memory. So we just know that there are some targets and some timelines that are set. And this is the standard slide that we know in terms of, what is there in compliance. So you have the global body, which is the IMO, which is on top, and you have the European Union, which I have represented below. So you have these years in which all these compliance is going to start. But one thing what we really need to understand from all this is European Union is leading the way towards decarbonization. Leave the fact that whether we will reach there or not, they have made already a very comprehensive, conspicuous plan on what they need to do with decarbonization. For them, it's very simple. We want to decarbonize this continent by 2050. And it's not just restricted to marine sector. They have made a plan which is called as a Fit for 55 plan, in which they have many other sub-projects that they are working on. So they are also making an innovation fund in which whatever tax is collected via the taxation system, which is something which I'll cover, which is the EU ETS system. They'll pool money there, and then that's what is there. We know that most of it is politically driven. We have a lot of economics which is there in the process. But I also believe that when you have more funds coming in, you have more technologies which will really mature. And obviously, with the economies of scale, the price might go down, is a positive way of looking at it. IMO DCS is this system, as you know, where you actually calculate CII. So this is one of the commercial angles. The CII, the aspect is not very popular because it does not take into account the cargo which is carried by the vessel. It's just looking at the fuel consumption. So it has not great people who are favoring that kind of metric. But the point is that the vessels still need to comply with the A to E rating. And if you have a charterer who's okay with the E rating, it's still fine with you today. But the problem is that if that owner is going for another charter, then he might face a charter who is looking at a C or a B rating. And that's where these clauses between owners or charterers are also happening more often now. But with other regulations happening, CII is still discussed. But yeah, it's not penalizing. There's no financial implication to that. And that's where now when we go into EU ETS and fuel EU, more people are focusing on that rather than the CII. But as you know, in future, IMO will come up with a universal carbon levy or some kind of global fuel index, which will most probably run between $400 to $600 per unit of what we call as an index. So I'm just covering EU ETS. EU ETS means the emission trading system of the EU. So it's based on a cap and trade system. Economics again, that if you come, you have to pay tax for whatever you are emitting. So the person who's paying for the fuel is the one responsible for paying that tax. And that tax goes to the administrative authorities, or let's say those member states who are part of that, continent. So this also means that it has got a price in the market. So that's why we call it as a cap and trade system. It's like share trading. And basis that only the price of it goes. So it's a win-win situation as per them. So you pay tax, but you also get a benefit that if you bring more technologies that reduce your fuel consumption, your CO2 reduces. So you can actually negate that price from somebody who's really polluting the environments because he needs to pay for that. So that's also some other project that we have, that we are doing this EU ETS full service for our clients who are mostly based in Europe or have vessels which are calling Europe. So this is the geographical scope of EU ETS. I mean, maybe this is new to few people, maybe already some people already know it, but basically it's defined on voyages which go into and out of the EU, which are inside the EU and which is outside EU. So if you don't have a voyage, you are not penalized. But if you are having a voyage which is intra-EU, the entire the CO2 is taken in, and now you have a phase-in period which is in 2024, but in 25 and 26 it will increase. So the amount of tax that you have to pay is going to increase unless and until you make some measure to reduce your emissions. Now I'll come to Fuel EU, another complex regulation. We are also trying to understand from our side what this really means, but this is also defined with that same rule, the same rule which is there for the geographical scope. The intra, extra, non-EU, that benchmarking is still there. But this is more of into penalties on the GHG intensity of the fuel that you are using. So they have already made a capping of conventional fuels. It's already above the cap. So obviously you need to pay. So why they have kept it like that? Because they want them to basically let go of conventional fuels and move into alternative fuels because the penalty is high. And when you look at European Union, we have to understand the cost, which is accumulation of both EU ETS and fuel EU. It's not that you are just paying only for fuel EU. You will have to also pay for the EU ETS cost. So if you also see the GHGs included here are the same, which is the carbon dioxide, methane, and nitrous oxide. And there is a calculation. That's also too complex for a normal person to understand. But we need to just understand that it depends on the fuel type and, the CO2 which is calculated. And this is the graph basically which is showing. So if you see from year 2020 till 2050, you have these limits and the reduction factors are there. So from 91.16, we are reducing it down to almost like 18.23 by 2050. So that's the amount of, let's say, a reduction which is needed in these years to reach that 2050 or let's say carbon neutral system. And on the right, you will see all the different fuels with their GHG intensity. And if you see the HFO, LFO, and the MDO, it's already above the 89.34 that you see here, which is starting from 2025. So the capping is 89.34, but already for these fuels, you see that it's 91.6. And so the compliance balance will always be negative. And so multiplied by that 2,400, which is the penalty, will be there. So these are some of the options for fuel EU compliance. So compliance balance is calculated, and based on that compliance balance, you will see whether your vessel has a deficit or a surplus. If it is as a surplus, well and good. Most of the LNG carriers have these surpluses. But for the deficit ones, the pooling is the best option if you have a good exposure in the EU. But for certain, let's say, vessels, it might be just paying off the penalty. So what I'm trying to say is that a combination of EU ETS and fuel EU cost is something that the shipping companies are already considering. So let's just take one scenario. So the vessel, how it's affecting, I have just put it both on a technical aspect as well as a commercial aspect. So technical aspect, as you see on the left, the performance optimization, the ESD, EETs that work on the ISO 50K digitalization. These are things that ship owners already have to think about. But when you go to the commercial side, you are calculating if a vessel is in EU, you also have to be abiding by the IMO DCS. So IMO DCS has this CII, and you also have the EU ETS as well as the fuel EU. So from next year, if you are having a vessel, which is a 110K DWT container going from Singapore to Rotterdam, and the total consumption is, let's say, 2,300 of HFO and 515 of MDO, the required value of that vessel, 6.29, the attained value is this. So you already have a D rating, which most of the charterers will always have a problem on. So the commercial flexibility of the vessel is already a question in terms of IMO DCS. But for EU ETS, the calculation says that so much of CO2 is so much of allowance based on the 2024, because that's 40%. And so this is the amount of euro that is to be paid in tax. That's a big number, which was not there till last year. And suddenly you are asked to pay so much of amount because your vessel is exposed to the EU and it has fallen with the EU ETS. And from next year, if the same voyage happens, the required intensity is 89.34, actual is 91.56. So the difference of 129, which is calculated as per the formula, the penalty is 82,863 euros. So a combination of both is what the ship owner and the charterer is exposed to. So what I'm trying to say is shipping is basically a chain which happens between the ship manager, the ship owner, and the charterer. Charterer is the one who's looking at the cargo. Ship owner manages the asset, and you have the ship manager managing it for the owners. So this means these costs are a big problem now, in the sense who pays for it. For EU ETS, it's already defined that the owner is the default responsibility. So he has to reconcile those costs from the charter. Why? Because the charter is the one who's paying for the fuel. But for fuel EU, also it goes with the same chain, but the responsible entity is the ship manager. So at the end of it, what we need to understand that everybody is in it. Nobody can escape the fact that we are not exposed to this regulation. So, this is not something that we need to consider. So these are the hot topics in discussion actually in shipping right now. People are already calculating the costs. They are looking at what is the exposure that I'm looking into. So if I am the owner of this vessel, I should already be calculating how many more years I would be able to operate the vessel and the costs that I am going to bear if the same employment is going to happen for the next 15 years. And the cost is going to increase because, as I was showing, that's the beauty of how they have done it. Every year, they are going to reduce that capping. So your penalty is going to really, really increase every 5 years unless you do something about it. And operational efficiency, or let's say technical efficiency, is not going to do much. So we have various decarbonization solutions. So this is also a standard template PPT that everybody is discussing, what are the options in front of us. Technology improvements are there, operational efficiency improvements are there. But if you see that mainly you have the alternative fuel, or changing over to alternative fuel is the most important, compliance option in front of the company if they have to look at fuel EU. It's just that it's not written properly. I am sorry for that, but actually the final PPT had it. So you will see that the bright green is the alternative fuel space. That's the only way that you are going to comply with these regulations. And the rest will be just a 15% according to us. And now we'll come to what we do actually for our clients. So this is basically vessel performance, hull performance, and machinery performance. So we set up these KPIs to ensure that operational efficiency is done on board the vessel. And actually, believe me, majority of the vessels are still not doing proper energy efficiency measures on board. We still have leaking systems. We still have bunker, or let's say fuel data not being reported properly. And this data comes from competent chief engineers and masters. It's because they have not been guided properly, because most of the merchant ship fleets work on simple principles. You have to make the ship safe. You have to pass the vetting inspections. You have to pass all this. And this thought has never gone to them that, data is also important. So I mentioned this in the DIM seminar also, that frequently we have these conversations with chief engineers and we tell them that whatever you do on board is of no use if you come at noon and write a bad report on fuel consumption and power reporting, because that sets the whole thing, it does not work in that favor. So I'm just covering some of the tools that we have, but what are we actually looking at? So we are looking at voyage optimization, hull and propeller performance, voyage execution, charter part monitoring, engine performance, all this. So all these small but relevant optimization methods are what we do. So we think that, added up, all this brings that change, but not in terms of fuel EU, as I was saying. It's just 15%. But the point is, we have a large chunk of fleet which is not energy efficient, which is not looking at what a company on a broader horizon should be looking at sustainability. So I'm just coming to energy efficiency actually on board the vessel is not being done properly. There are vessels which do, but finally it comes to the people on board. And that's why we stress a lot on the seafarers. Some of our numbers. So the number of vessels that we have done optimization and the fuel savings is what I have just mentioned here. Why I have mentioned this is because when I say that I have saved so much in fuel savings, and this is the CO2, this is actual saving because we intervened as a performance team. And a vessel which was to do a hull cleaning or to do an engine performance monitoring, we we actually preponed it because our analytics was telling that it's not going the right way. And so that's how we actually say that we have saved fuel. So you can't reduce fuel, you can only optimize fuel. So what it is supposed to, let's say, consume, it has to consume. But because of the intervention is what we have just mentioned. And that's mostly on the hull, as you know. And the main engine also, we see big issues, because in terms of reporting, a classic example is specific fuel oil consumption, which is basically your fuel consumption over power. But there are a lot of manual entry where the chief engineer or let's say the vessel crew just report, this is the consumption, this is the power, this is it. Nobody cross checks. Nobody really goes into what is actually happening on the engine. I have done that as a chief engineer, so I really know what is the difference that we have to make on board. And I think this was something which was covered already in the previous option. So finally, it's to economics and how you really understand the cost. So if you look at the primary costs now, and I was saying at this present condition, you have so much of regulatory costs. The fuel costs are comparatively, less, and you also have to look at the shipbuilding cost. But over the years, what will happen if you move to alternative fuels is that your fuel costs will increase, but your regulatory costs will come down. But the point here is that you have to make a fine balance of these three important regulations which are there. So my point is this: you have to evaluate a vessel by vessel. Every vessel is different because it depends, all these what you're talking about is depend on the operation of the vessel. Where is your vessel operating? What kind of vessel is it? What kind of regulations are the vessels exposed to? And the operational profile, how much is there? It's in the European Union, how much it is outside the EU, everything counts. Another important factor is if these IMO midterm measures really happen in 20. So that's an additional taxing for the global option. So that means if you are planning to sell off a vessel or at least retain a vessel for the next 10 years, you have to think about all these costs that's coming in. And then your business and the revenue and the profits also needs to be calculated in that way. So this is exactly what we provide from our side. So if a ship owner comes to us and says that this is what I'm looking at operating my existing vessels, and I was very unfortunate that I bought the vessel in 2021, let's say, and 2023, the CII and all these came up. And so I was not aware. So now I am a victim of all this. How can I still run my vessel, operationally run my vessel? So that's the kind of study and analysis that we provide. So that's the consultation that we do from our company for this. I'm just looking back at seafarer understanding this. So if you see one vessel which is out at sea, it reports to our platform, which is mostly used by ship managers and owners, and it's also reporting to charter. So on a daily basis, a ship reports to the owner platform and charter platform. Now, charters having to pay for the fuel, they have also established proper performance teams in that department, because I am paying those tax for that European Union, because as a charter, I am the one who has to pay for each and every ton of CO2. So he has become more careful now. And so he is questioning the owner who was earlier having all the data coming in. And what happened was, what happened was that earlier, this data was there only in the ship manager system, and there is a speed and consumption, as you know, that we are working on. So some of what the commercial teams under the ship owners were doing is that, okay, they would say, don't show too much of consumption because we know that it's over consuming, but reduce it because it's based on an owner versus charter ship consumption, metrics that we have to operate. Otherwise, we'll get a claim. But what happens is that you are reducing that consumption, but actually what's happening on board and what you're reporting is different. And so this is what the IMO is now telling, that the owners and the charters need to collaborate. My point is this, that it comes down to the seafarer understanding that his reporting has a big commercial implication because the charter is going to ask for that fuel that he's looking at. And this is the entire loop of the services that we do, starting from data collection to the verification, for calculating how much of CO2 is required, and then from there, the allowances which needs to come in, the receival, the accounting, verification, submission. So we do this end to end for EU ETS and fuel EU. So the point here is that there is a lot of opportunity. We have almost like 31 people in our team, and they are kind of having a lot of exposure to all this and to the new regulations. And we feel this is a big opportunity going ahead for the next 5-10 years, because this comes with a lot of commercial angle as well. So earlier it was just looking at technically getting the vessels efficient and performance and all that, but please understand that people are looking at it on a very commercial business angle, and so the services also will be much more important. We have a lot of software companies with performance, but I think at the end of the day, a client requires a person who does it end to end. That's the reason that we have started this, basically looking at all these services for shipping companies. So this is a list of services that we have. So thank you so much for your patient hearing. I'm not sure whether I have touched upon everything which is familiar to you, or maybe it's too complex, but yeah, open to any questions.
Thank you, Anil, for your valuable and excellent presentation. And you have thrown light on the sustainability and energy efficiency of marine vessels. And now it is time for the questions from the audience.
It's just a observation on your comment that shipping is not regulated now. My view was just opposite. Like shipping always got away with no regulation because it's so international. You don't have a way to catch the ship owners because they're using one of the most dirtiest fuel like HFO. They got away with it for so many years. Now they're forced to do something. Is the thought I had. So I just want to know if you...
No, I was just making the point that after 2018, when we had set some targets for decarbonization, is when we have started a proper regulation. That I do agree, but I'm saying that presently it's highly regulated. Because now if you have the IMO DCS, now with looking at CII and with this carbon levy also coming in, obviously you need to be very serious about end-to-end process. So I believe the opportunity is twofold. One is that there's a lot of consultation needed because a lot of shipping companies need to go through this digital transformation. We still have a lot of companies which just work on Excel sheets. And that's the reason why maybe AI to an extent might not give the real results, because the data quality till now is kind of very poor. So you must have good quality data to get a good AI model, I believe. That's the same struggle that we have now, although we really want to develop it. And secondly is the aspect of training as such, because the end user, I mean, the consumer has to pay for whatever it is there at the end of the day. And I think it has to come to a new level where the end products and services would be, costlier, but there would be a balance at the end of the day. It shouldn't be that somebody else is bearing the cost of someone else, and just one section of the world is enjoying and the other one is working for the other. So I think that new, kind of parallel needs to happen. So I'm just saying that I'm happy that it's regulated. I'm still of the view that if the technology is really mature, see, like people like you are all already there in the system. If just think about 1,000 people like that working around the world, creating those technologies, then I think then we should look at it at a positive. I'm also happy that they've kept these targets in between, so we really know whether we are headed in the right direction or not. I still believe for CII they've put till 2026. From 2026 to 2030 is what they might define, because they were not confident in putting till 2030. So I think someone is also there in those regulatory bodies who are more sensible. I am of the very vocal view that sensible people are not sitting making these regulations. And we need operational people to head all these things, And when you see these regulatory bodies, working groups, rarely 10% will be real operational people who have really worked. So that is also something I think at some point of time people will realize. And yeah, so that's why I put that seafarers need to understand commercial aspects. I was never exposed to a commercial aspect of shipping. I was exposed to when these regulations came in. So I think that's also bringing that change. So that's where I look at it optimistically. But yeah, I do agree to what you said.
Your services to existing ships or to new ships, or is it extended to the new designs?
Yeah, so we are collaborating with design firms to basically provide that kind of service. But mostly it's to, I would say, to existing ships, because, owners with ships with conventional fuel, they still have not realized what they are going to get exposed to. They still think that this is just like another IMO DCS or something, fuel EU and EU ETS. We have Japanese owners and Chinese owners whom we still have discussions with, who really don't know what they are going to pay next year. So that's the big problem shipping is facing right now. But we have also companies who are going there, reaching the amount and showing them the exposure. We are also doing the same thing. So we are telling them that you are exposed to a $1 million. Are you knowing that? So suddenly he's shocked to hear that he has to pay for that $1 million next year. And so he wants us to churn out a plan for the next 10 years. And that's where we go next and provide the kind of services that we do. That's where I was saying opportunities there.
Understood.
I just want to also mention, I was listening to Mr. Hari from SEDS yesterday, and I also mentioned to some of the faculty members, this is basically for the students. There's a lot of opportunity in India already. We really need not actually go abroad to make a kind of living that we dream about. Why I'm saying is that sitting here in Cochin, the department and basically the services, we are able to generate a reasonable amount of revenue sitting in Cochin. So this means that expertise is what they are looking at. People who can provide good quality services, what they are looking at. So if you're still okay going around the roads of Cochin, although there are a lot of potholes, but still at the end of the day, if you get a good amount in the bank and you're happy, I think that should be fine. Because everywhere it has its pros and cons. So I really liked what Mr. Hari was saying yesterday. So I think the new generation should always look at what is the power of India now and what is the power of India in the next 10, 20 years, and invest your life here, provide it back to the country, and grow together. Yeah.
Wonderful presentation. I've got two questions basically. One is you were explaining the different verticals you are working with. So I was wondering whether you are having some kind of insights into the slight modifications which can be incorporated on the existing hull forms. For example, you try to do a CFT analysis and try to do a modification on you recommend to have a modification on the stern part, stern optimization. Something like that, or you just putting the inputs in terms of cleaning the hull and just do the weather routing or kind of stuffs.
I cannot provide you those numbers because there are more of business implications. But one thing I can tell you is that we base our analysis and our recommendations on the data that is there. So that's the let's say leverage we have, because we have a lot of data from 2015 till present year of these vessels, and where basically they've done all these ESDs and EETs. So we have seen the actual percentage. So for us, it's not a vendor pitch that we do, that this vendor is much better than the other one. But we really see what was the consumption before, what is the consumption later. And that is the actual percentage savings that actually we show. So, so people ask me which company is better than the other one. I would just tell them in a very private conversation, but not opening up, because we have discussions, collaborations with a lot of vendors. But yeah, coming back to your point, we don't do it in our team. but we basically subcontract it to other companies. And we also have in the Schulte group, a Schulte Marine Concept, a full department, a wing, which is in China, which is looking at retrofits and new buildings. So we basically get some inputs from them as well.
Okay, so that was well explained. The second question is, now the industry is, going to a very kind of, difficult times, I must say, or opportunities time. Whatever it be, we are going to have a lot of requirements coming in line, maybe from 5 years from now. So my question is, I'm very sure that we will not be able to cater that much kind of orders coming into our order books. For example, if you take the typical case of the scrubbers, 2020 when it reached, the shipyards in China were getting flooded with orders, and they were not able to accommodate any more ships. But India was still not having any orders, if I'm correct. So we just lost that particular bus. Secondly, so in this scenario, you are going to have a lot of requirement coming in maybe from 5 years from now. So how are you planning to accommodate this much, large kind of requirement? How you are going to train your people, or how are you going to, get enough manpower for that matter? Are you doing something in collaboration with universities or, training institutions or your parent companies? How are you going to accommodate this much large requirement?
Yeah, so I'll put it this way. When I was in, I'm still with BSM, we had actually formulated the first vessel performance and decarbonization course. We are the only ship manager which is doing that. We have already 100 batches which are out of that. We have seen a significant change in the performance of those vessels in which the people who had passed out of this course really made that difference. So when we talk about operational efficiency, it is proven fact that people, when they know what is actually on a broader level and what they need to do on a daily basis, the change is evident. So this means that a lot of information and guidance needs to be there in shipping industry for people to understand this. I fully agree with your point that by the end of the next 5 years, we will have a lot of orders. But I have also understood something which I think you also and everybody understands, that shipping is very slow to move, especially the world market. See, Japanese owners, Chinese owners, they take their time in investing on something. I've gone multiple times there. Whatever we do, they never get convinced. Now the problem is this IMO midterm measure. So now they will wait till that time that is also finalized. So they will say that, okay, if my vessel is operating, what is the total cost that I have to give? I will work on what is the capex that I have to provide and see what is the lifetime of my vessel, or maybe scrap the vessel. This is what might be crossing their mind. So if you see, people have not taken any kind of decision till now. They're still waiting. Their general way is to observe things, as opposed to a culture which you see on the west side, especially in Europe. They've already made everything. So for them, it's first like you put a timeline and then you need to act accordingly. So I think this order will come in. So my point of view is there will be a lot of orders in terms of design. Yes, not a good expert to actually comment on it, but on services also there is a big opportunity. Because I'll just tell you one example. This taxation that we say about EU ETS, it's to actually pay the tax to the government or the Ministry of Transport of a member state. That's a big administrative process altogether. A lot of email chains needs to happen. You have to open an account there. There's a trading account. There's another account which is called as a MOHA account, through which these allowances needs to be transferred. Who's going to do all this? These shipping companies don't have dedicated departments to do all this. They have to subcontract this to agencies who will do it at less cost. So let's understand that if we have set up a team here in Cochin who does it for the entire shipping, that's a big revenue potential altogether, because these administrative tasks, these services, we are very good at. Indians are really good at customer service. I really feel that, because they think from the point of view of customer. They always put their, thinking in the shoes of the customer. That's the only reason that in 3 years' time, we started as a cost center and now we are a profit center. The reason is because we have understood slowly that it is not just support. You need to bring revenue and that revenue comes from good customer service. They really want somebody who will take it end to end and answers the questions to these. So I would say design plus operation and also a consultation will be the greatest business opportunity. And when I say consultation, is also meaning training.
I just beg to differ for one point, what you are referring. I mean, if I'm not taking much time. Now the scenario has changed, like some people design the ships and somebody operates it. People needs to cross their, individual watertight compartments and, go to the next compartment and understand what is happening out there. That's how the things are going to move, maybe, from 5 to 10 years from now. It is not like a naval architect designs a ship and operates by a marine engineer or operates by a nautical officer. People needs to learn things, not only just these aspects. We have to have some kind of understanding about the ML, the machine learning, and the AI applications. And I don't know, the our industry was not actually was not infected by the IT boom. I mean the shipping, but now I think all of us should learn some aspects about the IT as well as the computer applications and the ML and AI thing. So my concern still exists. I was just asking, how are you going to have enough manpower for this? Because if we want to do something 5 years from now, we need to do it right now, because the boys need to be graduated and they need to be trained slowly. They need to be trained and getting into this job. So how are you going to accommodate that? And when we profess like India is going to be the largest maritime provider of the world, but what is the manpower here? I don't. So that was my exact question to you. I mean,
so I would only say that you must have at least a sense of some investment coming in from the stakeholder to basically invest in resources right now. If I can just tell personally that I have invested in resources when I know that there is some investment coming in, because at the end of the day, at the end of the year, I need to provide my profit or bottom line. So in terms of services, I don't think that there is an issue, because see, IT people, I mean, with IT background are the ones that I have employed in my team who are running the AI and ML possibilities. I'm not even just mentioning that AI and ML we are working on. I don't know why people in my industry are already saying that we have AI models and things like that. We have tried to do that for some time. We have not entered a good solution there. But just imagine Maersk has chartered fleet. It's paying 50% of the energy efficiency that they have decided on a vessel. So 50% Maersk is paying for the cost and 50% the owner is paying. So it's a collaborative effort. So once that is done, and on the design aspect, if you have somebody giving that kind of service, then obviously it should be there. I'm just saying that there is positivity there because there is more collaboration happening in. So I'll tell you, I go for a meeting in which there is this owner and whose vessel Maersk is chartering. We have a discussion with the performance team and we both sit and evaluate what kind of vessels that the owner should buy if they want Maersk to continue chartering those vessels. So those discussions are happening. Earlier, charter was never part of the discussion. That's a different silo altogether. But now we have these discussions happening. So I think the demand will come. If I get somebody to tell me that, okay, I'll invest a $2 million in your project, the next day I'm going to search for people, and that manpower can come in if I can actually create some good remuneration here, is what I feel. Because maybe I'm mistaken, but I see a lot of people around me who are looking for good jobs and really want to set up things here, because they have reasons why they want to stay here. But I cannot, maybe not to a very expert level, go into the economics of how many, and that is something maybe I'm limited in with my information.
Got it, sir. Thank you. Yeah.
But it's good that you have given me a thought. So that is also something which I can note down and see how it's going to change.
Yeah, thanks. Yeah.
So thank you, Anil. We come to the end of the session. Thank you very much.
Thank you. When I started the conversation, I was anticipating 0 questions because, it's It's an area that is totally away from ship technology and what has been discussed. I'm happy that we have a little more time. Thank you.
Thank you, sir, for your informative presentation on energy efficiency and sustainability of marine vessels. Your knowledge and contributions have significantly enriched the session. I now invite our session chair, Professor Dr. A. Madhiyaragan, to present Sri Anil Jacob with a token of appreciation and a certificate. With this, we conclude the session. A heartfelt thank you to all the speakers and the session chair for sharing their knowledge and expertise in the field of marine hydrodynamics and sustainable technologies. I now invite Dr. Sadish Babu, HOD, Department of Ship Technology, to present a memento to Professor Dr. A. Madhiyaragan as a token of appreciation for his guidance throughout the session. High tea has been arranged outside, so please enjoy. After that, we will move to the valedictory function. So everyone, please be at 4:45.